Arithmetic sequences. The sequences that we'll be looking at come in different types, and the first type we're looking at is what is called an arithmetic sequence. These are sequences that are generated by adding or subtracting from one term to the next. So this sequence here is plus 5 between one term and the next. This one here is minus 5. That was very uncreative of me. I should have come up with something more exciting. These are arithmetic sequences. To go from one term to the next, you add or subtract. So a little definition there. Now when we are using arithmetic sequences, that fixed amount that we add or subtract is the common difference. So common means shared, and difference is the difference between each term. To calculate the common difference, like a lot of the time you can just look at it and go, it's 5. It's minus 5. But to calculate the common difference, it's the common difference is given as D, and it's a term minus the previous term. Now you'll remember that our any term would be Tn, and the term before Tn would be Tn minus 1. So for example, T2 minus T1, T3 minus T2, all of those would give the common difference. So for this one, the common difference is T2 minus T1, which is 45, minus 50, which is negative 5. So you need to be able to calculate the common difference. Sometimes, of course, you can just see it. When the common difference is positive, so that means it's greater than 0, then the pattern will increase. So here my common difference is 5, it's positive, and the pattern gets larger. Here the common difference is negative 5, and the pattern gets smaller, so when the common difference is less than 0, the pattern decreases. Now I should get into the habit of always putting a formula into a little box there. And here is a very important rule. Now, to write recurrence relationships for arithmetic sequences. So a recurrence relationship, you'll remember, is where we follow a rule to go from one term to the next. And when we write a recurrence relationship for this, we would write T1, the starting term is 10, and to get Tn plus 1 from Tn, so from any term to get the next term along, we would add 5. Now you can pretty clearly see that 5 is our common difference. And we're going to write a general form of an arithmetic sequence. We'll always have the rule T1 is the starting number, and we use A for the starting number, So the first term is often known as A, and that's the same as T1. And the rule is Tn plus 1 equals Tn plus the common difference. Now, if the common difference was negative, that would be Tn plus a negative common difference, so it would come out as negative. But this is the general form of an arithmetic sequence. Any term is equal to the previous term plus the common difference, and the starting term is known as A. So, a couple of different types of questions we might need to do. I've shown you how to find the common difference. One type of question we might use with that is to ask or show that a particular sequence is arithmetic. If a sequence is arithmetic, it will have a common difference. That is, the difference between term 1 and 2 is the same as between term 2 and 3 is the same as between term 3 and 4. So if you want to show whether or that a sequence is arithmetic, you have to check the common difference, or the difference between each pair, to show it's a common difference. So the differences here, 28 minus 21, the first pair, 35 minus 28, the second pair, and 42 minus 35, the last pair. So you have to show that these are common differences. So 28 minus 21, 7. 35 minus 28, 7. 42 minus 35. What did I do wrong? No, I did it right. Good. 42 minus 35, 7. Because the differences are common, that is, they are the same for each, we would say the differences between successive, that means one after the other, and we say they're constant, that means they stay the same, it's the same difference. Therefore, the sequence is arithmetic. You could also get away with saying D equals 7, therefore arithmetic sequence. That would be fine too. So this one, we check the differences. Second minus first, 6 minus 2, okay, difference is 18 minus 6, 54 minus 18, and this is not looking good. There's no common difference. Therefore, the sequence is not arithmetic. So, if we want to prove that it's arithmetic, show with working that there's a common difference. We need to be able to write a recurrence relationship for an arithmetic sequence. And you will remember that the form of a recurrence relationship is T1 is A, Tn plus 1 is Tn plus D. I don't know why I went to a different colour, it just looks pretty. So you identify A, the first term, it's 12, D, showing working, 20 minus 12 is 8, then substitute those into the rule. T1 is 12, so the first term is 12, And all you need to change here, Tn plus 1 is Tn plus 8. So it's just formalizing how we find what's added or subtracted between each term and adding a general rule for how we write our rule for a sequence. So this one here, write the formula for an arithmetic sequence. T1 is A, Tn plus 1 equals Tn plus the common difference. Find A, the first term. Find the common difference. 11 minus 14 is -3. Substitute in these values. T1 is 14. Tn plus 1 is Tn minus 3. So that's it. That's the rule for an arithmetic sequence.